Hello, this is Muhammad Abdullah Khan from BEMTS 2A, roll number 221748, and in this video, I'm going to be doing a quick review of a subject that we had studied in the previous semester named Electric Circuit Analysis. To begin with the review, we will first see the basic circuit elements, which are five basic circuit elements, including voltage sources, current sources, resistors, inductors, and capacitors. To begin with voltage sources, we can explain them as a voltage source is a two-terminal device that is connected in a circuit and provide continuous pressure for the movement of electrons in the circuit. Basically, it is a path for current to flow on. The common practical example of voltage sources are cells, batteries, generators, and other devices that generate a voltage. Voltage sources are always replaced by a jumper in simplifying a circuit. A jumper can be explained as a line or a wire in place of the voltage source previously. After voltage source comes current sources. The current source is a simple circuit. It will be defined as a current source will provide a current which remains constant regardless of the load placed at its output. Resistor. Resistor is a two-terminal circuit element that has constant ratio of the voltage across its terminals to circuit through its terminal. We can also explain a resistor as a resistor is a passive two-terminal electrical component that implement electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels to divide voltage, bias active elements, and terminate transmission lines among the users. The value of ratio of voltage to current is the defining characteristic of the resistor. Inductors. Inductors are one of the most basic inductors and capacitors are one of the most basic elements used in electric circuits while making electric circuits and other applications. An inductor is a passive voltage electronic component that temporarily stores energy in the magnetic field when electric current flows through the inductor's coil. Inductors are simple coils of wire. Inductors are of three types: air-wound, wire-wound, and could also be circular around. Can also be wound around a circular form. Inductance is measured in henries. After inductors, we have capacitors. A capacitor is a device that stores energy in an electrical field. Capacitor can also be used. Capacitor. The principle of working of capacitor it consists of two conductors in close proximity and insulated from each other. A simple example of such a storage device is a parallel plate capacitor. If a positive charge with total charge positive Q are deposited on one of the conductors, an equal amount of negative Q is deposited on the second conductor. The capacitor is said to have a charge Q. The unit of capacitance is farad. One of the most basic laws of electric circuit analysis is Ohm's law. Ohm's law states that the current through the conductor must be between 2 points, is directly proportional to the potential difference across the 2 points, and inversely proportional to the resistance between them. The mathematical equation describes the relationship V is equal to IR. V is equal to IR is one of the most basic equations that can be used in which I is directly proportional to V and is inversely proportional to R. Okay, after Ohm's law, we have KCL, which is Kirchhoff's current law. Kirchhoff presented two laws which were current and voltage laws. KCL states that the sum of current entering a node will be equal to sum of current leaving the node. At any moment, the algebraic sum of current flowing through a point in a network is zero, or in an electrical network, the algebraic sum of currents meeting at a point or a junction is zero. The law is also known as point law or current law. A basic example is given of KCL, in which we can see the total current is at from one side is 9 milliampere, and the sum of other currents is equal to 9 milliampere on the other side. After KCL, we have KVL, Kirchhoff's voltage law. Kirchhoff's voltage law will state Kirchhoff's voltage law is a result of electrostatic field being conservative. It states that the total value around a closed loop must be zero. In a closed path in a network, the algebraic sum of the IR product is equal to the EMF in that path. IR is the value of V. After KVL, we have Thevenin's theorem. Thevenin's theorem states that any linear circuit containing several voltage sources and resistors can be simplified to a Thevenin equivalent circuit with a single voltage source and resistor connected in series with the load. There are four steps of Thevenin theorem. First, we remove the load. After removing the load, we determine the voltage seen by the load, replace the voltage source with a short. To not short of the power supply, there is a difference. Determine the resistance seen by the load R Thevenin. First of all, we will remove the load resistor, just like here, represented by AB. After that, we will find the voltage across that node AB, which will be equal to the Thevenin voltage. The Thevenin voltage is the voltage which is known as load voltage. Then we replace the voltage source with a short, that will be a jumper. Then determine the voltage seen by the load V Thevenin. We will apply current voltage divider rule. Voltage divider rule at resistor R2 means R2 will be above, which will be divided by the sum of total resistance, which will be R1, R5, and R2 multiplied by total voltage. Simplifying this equation will give us 4 volts. Determine the resistance of the load R Thevenin. R Thevenin, we have to determine R Thevenin across AB by simplifying. As we know that it will be given as R3 plus R1 plus R5, which is parallel to R2 plus R4 if we start from the right. So after simplifying this, we will get 8.4 kilo ohms, and then we will get an equivalent Thevenin equivalent circuit, which has a single voltage source and a resistance connected in series with the load, as I explained above. After KVL, we have Norton theorem. By reducing the elements of complex circuit uh, to a single current source and a single source resistance which supply power to the load, a simple circuit can be created, which is Norton's circuit. Norton's theorem states that any linear circuit can be simplified to an equivalent circuit consisting of a single current source and parallel resistance that is connected to a load. First of all, we remove the load as previously. Then we find the current seen by the load. The current seen by the load will be I Norton. It has similar steps to the Thevenin's voltage. Just we also have the same resistance as Thevenin's resistance. Just it is labeled as R Norton. Only the difference is in a Norton's theorem we have to deal with current, which will be I Norton. Short circuit the power supply. First we short the power supply, then we determine the resistance seen by the load. The resistance seen by the load will be R Norton. After that, we will implement a simple equivalent Norton circuit, which will have a I Norton, which we calculate, and an R Norton. The thing to ponder is that we will first, the current source will be in parallel with the Norton's resistance. This will give an equivalent Norton circuit. So this was a quick review of electric circuit analysis.